Hey guys, welcome back. In last session, we have explored numeric data types in Python, integer, float, and complex numbers. I hope you were able to understood that and you have also done some hands-on for methods of integer and float. In today's session, we'll explore the most important data type from data engineering perspective, which is a dictionary. If you ask me which one data type you use in your day-to-day data engineering work, I will say it's dictionary. So, we are going to study dictionary in great detail. Now, before starting with the dictionary, we'll first understand why dictionary is so important in data engineering world. Now guys, whenever you are building a data engineering pipeline or data engineering framework, we need a way to store properties, configurations, and metadata. And this is where dictionary is really powerful. So generally we build a config driven things. So config driven data engineering pipeline or config driven framework. And to store those config, we need some data type, and there we mostly use a dictionary. Okay. Let's say we are building one config driven pipeline. If you are not familiar with the config driven pipeline, let me explain it quickly. Let's say we have a scenario where we need to load 100 tables. Okay, so we have 100 table in some source and we need to load it to the cloud. Now, to design this pipeline, we need following details. What are those? Your source table name, right? So we can query that. Then your target table name, so we can ingest data there. Okay, then there may be some table with the full load and some with the incremental. So we need to know load type for each table and key columns. Okay, can we build a separate pipeline for each table? We have 100 tables, so can we build separate pipeline for each table? Just think about it. Yes, you can. But if you do that, you will end up building 100 different pipelines, right? Maintaining these 100 different pipeline will be very difficult, right? Now let's say you want to load another table, 101st table. Then you need to create the pipeline again, the new pipeline. So guys, this approach is not scalable. We cannot scale it. Okay. In real world data engineering project, we usually build a config driven or metadata driven pipeline. So what are those config driven or metadata driven pipeline? Let me explain you. So in this case, all our metadata is stored into one table or file. Let's say as of now, we are storing it into a table. Here, if you see, we have one entry for each table. Similarly, we'll have 100 entries for 100 tables. And this is how our metadata will look like. So we have source table, target table, load type, and primary key, and values associated with those. So these are keys and these are values associated with those keys. So for each table, we'll store it. And this is nothing but a dictionary. So we are storing our metadata in the form of dictionary. After this, we'll load this metadata, right? Let's say this square box is our pipeline, okay, config driven pipeline, which we are building. We'll load this property. So we'll load this metadata. Then we'll pass this metadata one by one inside for each loop. So for each table, we'll pass this metadata. Then the pipeline will query a table based on these properties, whatever config properties we are passing. So first time it will query this customer source table and fetch the data from it. So this query will be parameterized, something like select star from and table name. Now table name will be populated from this table properties. Okay. Once that is populated, in next step we'll copy that data to the target table. Again here your target table is parameterized. Okay, and those properties will come from your metadata. Now guys, if you need to load 101st table, do you need to do any changes in the pipeline? Just think about it. And obviously, the answer is no. You just need to make new entry into your metadata table. Okay? So, you can easily load that table without changing anything in your pipeline. this is the config driven pipeline. So what exactly happens here? At runtime, pipeline reads the config values dynamically. These config values pipeline reads the dynamically and process the required tables, right? We understood what are config driven pipelines and how dictionaries are useful in storing these configs. But guys, that's not only use of dictionaries. There are a lot of other uses. But I just wanted to give you some background so you develop some interest in studying dictionary. Now we understood the importance of dictionary. Let's see what are the dictionaries. Okay. Now guys, dictionaries are nothing but a Python data type which store data in the form of key value pairs. Okay. So in our config driven pipeline also we saw we are storing our data in the form of key value pairs, right? So this is nothing but a dictionary. Now let's move to the code editor and create one dictionary. Let's say I'm creating a dictionary employee. In this dictionary, I want to store name of the employee, then age of the employee, and skills of that employee. Okay. So this is nothing but our dictionary. Here, name, age, skills are the keys, right? And Akshay 30D are the values associated with those keys. You can compare this to the real world dictionary. In real world dictionary, keys are nothing but words, right? And values are meaning of those words. Okay. And in our Python dictionary, keys helps us to identify the data, right? And values are nothing but the actual data. Okay. Now guys, in previous sessions for integer and float, we understood that integer are object of class int and float numbers are object of class float. Then what about dictionary? This is also object, right? So it must be belonging to the some class. Let's check it. So let's see, this employee object belongs to which class? This employee belongs to the class dict. So what does it mean? Your employee is object of class dict. Since this object belongs to the class dict, this class must have the constructor, right? And we can create this employee object from constructor as well, right? So let's create employee dictionary using constructor of dict class. So here we need to pass those key value pairs. Okay, I'll pass name, age, and skills. So this is another way of creating dictionary using constructor of dict class. Okay, now if I can copy this same, right? Yeah, and let me comment out the above part. Okay, now if I run it, see, this is again dictionary. So we already know what happens here. Same like integer and float object. As Python sees the dict, it calls the constructor of dict class, passes this input to that constructor, and constructor returns and dict object. If you forget about the constructor, let me explain it quickly. So we will have class dict, right? I already explained this, right? Then it will have a method double underscore init double underscore. Okay, and it will have logic to return dict object. Fine. This is nothing but a constructor. So when you write this code, your this underscore init underscore double underscore init double underscore method is called, which returns the dictionary object. Okay, fine. Now guys, there is one more thing. If dict is a class, there will be some method associated with that class, and object of that class, which is an employee, can access those methods, right? We studied this. So let's see what all methods available with this dict class. We know there is a method dir, and if we pass the class name to it, it will return all methods associated with that class. So see, these are methods available with our dictionary. Now guys, Dictionary is really important for us from the data engineering perspective. So we are going to study few methods. I will not be able to cover all methods, but I will try to cover some methods, and then you can cover remaining from the documentation. The first method is to check how many items present inside your dictionary, which is a length. So let me create here dictionary again, and let's apply this method. This D is nothing but the dictionary. Okay, so let me call this method and pass our dictionary, which is an employee. See, it returns 3. So our dictionary has 3 items. Okay, second method is to access value for particular key. See, name, age, skills are the keys for our dictionary. Suppose we need to access value, this 30 value, so we can always access it using the key. Okay, so if you want to access value 30, you need to specify the key of that value. So my dictionary is employee, and I want to access value of key age. Okay, so I'll pass that key to my dictionary. See, it returns that value. Okay, so this is how we can access the particular value. Now sometimes we need to check if particular key exists in the dictionary. So we can check using this method if key is present in dictionary. So what I will do, print what key I want to check, age in employee. So basically this method will either return true or false. If key is present in the dictionary, it will return true, otherwise it will return false. Here our key is already present in the dictionary, right? Age is present in our dictionary, so it returned true. Now let's try by passing some other key which does not exist in the dictionary. Let's say name underscore 1 in employee. In this case it should return false. Okay, and there is one more method opposite to this method, which will check if key does not exist in the dictionary. In that case it will return true, and if key exists it will return false, just opposite of it. Okay, there is one more important method. Suppose I want to change value at particular key. Let's say I want to change value of age, so we can do that in dictionary. So my dictionary is employee, I want to change age. Okay, and change it to the 40. Previously it was 30, right? Let me print dictionary before changing the value and after changing the value. See, age previously was 30, now it changed to 40. Now guys, I have one question for you. We are able to change the object in dictionary. Okay, so we are able to modify dictionary. So each dictionary is mutable or immutable? And I hope you guys guessed it right. It's mutable. But guys, then I have a follow-up question. We have multiple different data types in the dictionary. Name, which is a string, age, which is a int, and skills, which is again string. And we changed the age, and it is of data type int, and int are immutable. Then how we are able to change the immutable data type when we are saying dictionary is mutable? Just think about it. Okay, I think you guys are confused. And whenever we have confusion about immutable and mutable, we will always draw the memory diagram. So we have employee variable, which is pointing to dict object, right? It has created some dict object in Python memory. Okay, so this is nothing but your Python memory. Fine. An employee is your variable pointing to some memory location in Python memory. Okay, let's say this dict object is stored at which location. We'll check here and give exact value. So if I check ID of employee, right, it should give me the memory address. See, it's stored at this location. Okay. Now this dictionary object again storing where some items, right? This dictionary is again storing some items. So what are those items? We have first age, sorry, name, right? Then we have age, right? Then we have skills, right? Now guys, the items inside the dictionary again stored at different memory location, and our dictionary object is just pointing to those memory location. How this is possible? Again, we can prove that. Let's check what are the memory address of these keys, name, age, and skills. If they are different, obviously it is not stored where your dict object is stored, right? So we can check those data type. So let me copy this. So first we need to check where key age is stored, right? Then similarly, we want to check for name, then for skills, right? Okay, let me do this before changing the value. Okay, so I'll do this here. Don't get confused with so many memory addresses. We are just checking the memory address of dictionary and items of that dictionary. Okay, if you see guys, this is the memory address of our dictionary object, and again these three are different memory address. So your items of the dictionary are again stored at different memory location. So our theory is correct. So I think this is the memory address of age, right? Then second one is name, and third one is skills. Okay. Now after this, what we did, we modified the age. This is one of the item of the dictionary which we modified. Now let's check memory address of age. What happened to that memory address? So I will comment out this so we can compare the memory address of age because it has changed. See guys, your memory address of age before changing was different, and after changing the age is different. So your dictionary item which age, which is of type int, is immutable. Okay, so what happened here in memory, it has created new memory location. It does not change the existing because age is immutable. Okay, so it has created new location here, and this is your new memory address. If I can change that to the 40 and this memory address, the new one. Okay, and now your dictionary object is pointing to this age. So what we understood from this, your dictionary is mutable. So you can modify the dictionary, but items inside dictionary can be mutable or immutable depending upon their data type. Suppose we had a list here, right? So list is a mutable, then list would have modified at same place, right? It would not have created new memory location. Okay, I hope this is clear, and this is the important behavior of the dictionary. Okay, so dictionary is mutable, but items inside the dictionary can be a mutable or immutable depending upon their value. Okay. Now guys, this is a really important concept and it will be really helpful to you when you write the complex code. Okay. So just revise it if you don't understand. Okay. Now we'll study the next and important method, which is copy. Okay. Now this is really interesting guys. Just pay some attention. Now guys, for this, let me create new dictionary. Let's say D1. Okay. Curly braces. So remember this syntax. Okay. We will create dictionary under curly braces. Let me again give name and one more value, maybe age. Now guys, you can always do D2 equal to D1, right? And print your D2. See, this is your same dictionary, right? Let me comment out this above part as well, so we don't get unnecessary prints. Okay, I hope that's fine now. Now your D2 is same as a D1, but what is D2 here? Is it a new dictionary? Let's check that. We can check that, right? Let's check ID of D2. So and ID of D1. So we'll get to know whether they are different dictionary object or same only. See guys, both pointing to the same memory location. So again confused? No need to confuse. We'll draw the memory diagram. So we have D1 equal to D2. This is our scenario. Okay. Now we have D1 variable. Then we have this Python memory. And inside here in Python memory, we have dict object. Okay. Dict object. If I can write that correct. Please bear with me for spelling mistake guys. Okay. Now this is at memory location. This whatever it is. Okay. And then we already know we have items inside dictionary. So they will be stored at different memory location. Okay. So we have name, Akshay. Let's say as of now it is stored at this memory location. I will not give the exact memory location. Then we have age. What was the age? 30, right? Age 30 stored at memory location 202. Okay. And this dict object is pointing to these two items of the dictionary, and your D1 variable is pointing to the dict object. Okay. Now, when you say D2 equal to D1, you are just pointing another variable D2 to same dictionary D1. Okay. So what happens if you modify D2? Your D1 also gets modified because at the end they are same object. They are pointing to the same object. So this is risky guys, right? If you want to copy some dictionary and you want to change something in the second dictionary, not in the parent dictionary, and if you do like this, you will end up modifying the original dictionary as well. Now when you will be able to understand this, when you know these internals, right? So that's why I am stressing a lot on these internals. So guys, please understand these internals. Okay. Now what I told you, if I modify my D2, okay, let me modify D2, let's say name to something else, Ajinkya. Okay. Now in this case, our D1 also gets modified. Let's see that. Because both at the end, if I can write the correct spelling, yeah. Because both of them pointing to the same memory location. See, both the dictionaries got modified. But I want to create the copy. Then how we can create the separate copy of the dictionary? Then it's possible using this copy. Okay, let's see that. Let me comment out this. Okay, so when I need to create a copy, how can I do that? So I want to create D2, which should be a copy of D1. Okay, now let's check ID of D1 and D2. Now if D2 is a separate object, it should have separate memory location, right? See guys, both are pointing to the different memory location. So we have a new object, okay, copy of the D1. But guys, here is also twist. What is the twist again? Now guys, if you check ID of any item from the dictionary, let's say name, okay, so let me check ID of name from dictionary D1, then ID of name from dictionary D2. See guys, both are the same. Now you will say to me, first you told that when we want to create the separate copy of dictionary, we can do the D1 on, we can do the D1 dot copy. It will create the different dictionary. Then again, items of the dictionary are pointing to the same memory location. So what exactly happening? Again, we are confused. Then again, solution is go back to our blackboard and draw the memory diagram. Okay. So if I can copy some part from here, right? I can copy this and we can modify the same diagram. So here what we are doing, D2 equal to D1 dot copy, right? And we saw that D2 created the different object, right? Python memory has created the different object. Let's say something different, right? I will say something else. Fine. But these items of the dictionary, these items of the dictionary are shared, guys. These items of the dictionary are shared between these two. Okay. Let me do like this. So these items of the dictionary are shared between D1 and D2. That's how Python behaves. So it is creating a new dictionary object, but items inside the dictionary are shared because they are common for both the dictionaries. So what Python is thinking internally, it's thinking why to waste the space? If items of the dictionary are same for both of them, then we can store them shared. But now let's say you are changing one of the item. Okay. Now guys, this copy behaves differently for immutable objects inside the dictionary and mutable objects inside the dictionary. Now currently we are in scenario 1. We have the immutable objects, right? We have the age and name, so string and int, and both are immutable, right? Now what happens in case of this? Let's say we change something for D2. Okay, I will change name to Ajinkya, like how we did previously. And now tell me guys, what will happen to the D1? Just think about it. Will something get modified in D1? No guys, nothing gets modified. Why? Because your name is immutable, right? So it creates the new memory location, and just your D2 will be pointing to that memory location and D1 will be pointing to the original memory location. So how it will look in Python memory, so it will be clear for us. Okay, so here what will happen now, your D2, right? D2 will have name, right? We are changing the name Ajinkya at some other memory location, and your dict object, right? Here age will be pointing to the shared memory location and name will be pointing the newly created memory location. So nothing changed for your original D1, right? Right. But for D2, it created the new memory location. So copy works fine in case of immutable objects. There is no harm to the original dictionary. But let's say now we are copying dictionary with the mutable objects. So let me create a dictionary with the mutable objects. Okay. I will comment out this. I will take this dictionary and I just want to change the items of the dictionary. Okay. So I will change. Let's say we are storing numbers, which is a list in dictionary D1. Now see carefully, guys. I will create a copy of this dictionary. It will be at new memory location, but these items will be shared, right? So let me draw the diagram. Okay, I can copy the same. Will modify this. This is more easy to modify. I can, if I can copy that properly. Okay. Now this is your copy in case of immutable objects. So in this case, there is no harm to your parent dictionary because immutable object cannot be modified and new object will be created at different memory location. Now this is our D2 equal to D1 dot copy in case of mutable object. Okay. Now what happens here? We have a list, right? So and we have just one element inside the dictionary. Okay. So we have numbers 1, 2, 3. Okay. So that's some memory location. Let's say 100. And we have then D2. Since we are creating the copy of it, it will create the new object, right? So it has created this new object. I will give some different memory address, right? And this list, as we know, will be shared between both of these, right? Now, guys, if I modify D2, will D1 get modified? Just think about it. Even it is a copy, separate copy, but the items of the dictionary are shared. Guys, D1 also gets modified because here this list is a mutable. The items of the dictionary are mutable and we can modify the mutable items. So it will get modified in place and both your D1 and D2 are pointing to the same memory location. Let me prove that. Let's see here. So we are coming to the end. Don't worry too much. Just concentrate. So let me modify D2. So in D2, I think we did some mistake in code. Let me see that. Okay, append. Yeah, we need to pass it inside braces. Okay. So this is nothing but a method on your list, right? Okay. Now, if I print this, see guys, your D2 also get modified and your D1 also get modified. So, what did we learn? When you do a copy and if your elements inside dictionary are mutable, then your original dictionary also gets modified. And if they are immutable, original dictionary does not gets modified. Does not gets modified. In case of copy, you will create new dictionary object, but items inside the dictionary will be shared. Okay. And if items inside the dictionary are mutable, there is a risk if other dictionary gets modified, your original dictionary will also modify. And if items are immutable, then there is a no worry, because new item will be created at new memory location and there is no risk to your original dictionary. Now let's say I have a scenario where I need complete different copy of the dictionary. I don't want anything shared. Okay? Because that list contain mutable and immutable items, and I don't want any risks due to which my original dictionary gets modified. So do we have something? Yes, we have. There is a method deep copy. Okay? So we need to import this method from copy module, from copy, import deep copy. Okay? So we'll use the same example here. I just want to show you that it does not share the items of the dictionary. It will create totally new dictionary. So this is my D1. Let me create D2 quickly. Deep copy D1. Okay. And let me print ID of both D1 and D2, which is obviously separate. Sorry, which is obviously different. So different in case of copy also, but items inside dictionary were same, were shared. Now let's say items inside dictionary. ID of D1 and numbers. And let me copy this. Okay. So in case of copy, these locations were same because items in the dictionary were shared. But if you see in case of, okay, if you say in case of, I I myself got confused. We have D2, right? I was printing the memory address of D1 only twice. So I thought how deep copy is behaving differently. See, your D1 is stored at different memory location. Items inside the D1 is stored at different memory location, and items inside D2 is stored at different memory location. Now you have one assignment. Try to draw memory diagram for this, for deep copy, so you get a clear understanding. Okay. Now guys, there are other methods as well, but we can't go through all those methods. But I gave you the idea that how you want to explore those methods. Okay. So my expectation is similarly you explore other methods and do hands-on for them. I will share the documentation link in the description of this video. So that's all from my side for dictionary. If you are enjoying this series and this kind of teaching, please like, share and subscribe to the channel. And please share your feedback in comment section. That will definitely encourage me and help me to improve my content as well. Thank you guys. See you in the next video.